Good morning, everyone. Welcome to our webinar on WENZEL design philosophy. My name is Drew Shemenski. I'm the president of WENZEL America, and we want to talk today about machine design, system design at WENZEL, and we want to share some insight into our philosophy and talk a little bit about how our history impacts the design of our systems and sort of what's at the center of the vision for R&D for us. So we'll start off by, let me introduce my colleague, who's the leader of our R&D team at the factory in Germany, Dr. Christian Wuttke.
Hello, everyone. Thanks, Drew, for having me here. How are you?
Thanks for being here. I'm doing well. How are you today?
Yeah, fine.
All right. So the first thing I want to start with, Christian, is tell us a little bit about yourself and how you came to be leading the R&D team at WENZEL and kind of what your path to that was and how long you've been with us.
So before I came to WENZEL, I did my PhD actually in quantum optics, and this somehow got me into this. So I'm a physicist, and this made the bridge to WENZEL because we have a lot of optical probes at WENZEL, and so I started as a development engineer in 2014 here at WENZEL, and from that I moved up the ranks to head of systems engineering, which sort of cares about having all those components working together as one solution. And from that, I got up to be head of R&D, which I do now since 2016, and having a lot of fun there.
Excellent, excellent. So not necessarily really a direct path for you from school to here, being a physicist and then making CMMs and other inspection systems.
Yeah, the good thing about physicists is they know about all that stuff a bit. Yeah, it's you do optics, you do mechanics and physics, and also some electrical. I wouldn't say electrical engineering, but at least electricity. So we have a very broad view of what is happening, and I think this is not so bad because it gives somehow a different view on what's happening inside a machine, and because it sort of covers all the areas.
Okay. So how does that kind of play into the vision for how we design systems at WENZEL, and what's your philosophy of that?
Yeah, I think it fits quite nicely because since I look at the product as a whole thing, you have all those components, you have the machine, you have the software. I also did some software in my studies years. It's sort of the same thinking that we try to bring into the WENZEL product. It's not only the machine that you have to have there, it's also some software components which you have to integrate there. And this all has to come together as a whole product so that it works for the customer. It doesn't help anything if you have a good machine and have a problem with the optical probes or they don't work together. And so I think this is basically the idea that we are having. We're not selling just a machine, but we want to have it designed as a whole product where all the components fit together so that this makes up a solution for our customers to work perfectly.
So the main focus is on the customer situation and the customer problem and the work that they need to perform, and then we design backwards from there.
Yeah, it is like that. Of course, sometimes we also have new ideas where we say, okay, so for instance, if you look at the roughness probes we have introduced, this was a principle that one of our engineers has made in his PhD thesis, and he was a complete specialist. So this is also somebody which we bring into the WENZEL family and then design that into a product. But typically, we think as from the customer side, what he wants to do with the machine and how we can actually solve his problem. And this can make major differences, like having a whole new machine design, or it can also make like smaller things where you think about some details, how to interact with the machine and so on.
Interesting. Have you had any situations where we take direct customer feedback and then put that into the design process?
So yeah, actually for smaller things and for bigger things, it's so at some point when we have finished the SF87, then people were coming to us and said, okay, this is a great machine, but I need a robust machine which has a bit more measurement volume. And this is how the SF1210 then came to life, yeah, where you have to have a intermediate design, and yeah, where we had to think about how to, whether we could adapt one of our own older machines or older designs, and at some point then realized no, customers were telling us, no, we need something robust that has very rigid guideways, which can handle all the dust and the oil and all that stuff. And so this is something where air bearings can come into play up to a certain extent, but up to at some point this sort of doesn't work very well. And that's where we said, okay, come on, then we'd rather do a new design and go to the SF1210. But sometimes it's also some stuff which comes from you guys selling the machines. I have one example for you too, which was when we sold our first CTL actually, where the customer said, okay, but I want to do some measurements, or I want to look at a video how a process works inside of my machine. And this is why I need some power inside the machine, or I need some pressured air or something, yeah, or some lines for making controls while we have the X-ray on. And that's where, I mean, we're as Wenzel, we're always saying we're flexible, and that meant for us, okay, let's take up the challenge, and then we put some wires more into that, and to talk to the customers how we can actually make it happen for him. And this was basically, I think, 4 weeks before delivery or so. So wow. It was really a tough challenge to.
That's
yeah, but I mean, okay.
Time frame.
Exactly, yeah. But we made that, and it worked, and it's actually inside the first CTL that's leaving the works, I think, next week. So we got it done.
When you have an improvement like that to a machine, does that become part of the standard options then for CTLs in the future, or is that a one-off just for that customer?
Oh, we have to look into that. I mean, there are sometimes some safety considerations as to why we don't put that perhaps not into the line, but it's also something which we should talk about. Yeah? If several customers come to us and say, okay, we want that or we want that, then we just put it into the standard. Otherwise, we do it a few times as a customer-based solution. I mean, we have a strong team here that actually just handles this kind of situation. So it really depends on whether customers like that kind of feature and request it more often, and we put it into standard. I mean, one of the things that we actually put here in standard is we need this power supply, which can handle this kind of breakdowns, line breakdowns. And this is also something that particular customer wanted to have, because it was, I think, in Portugal, the landline is not that well. And so that's, or the power grid. And that was the point where we said, okay, then we hurry that up and just put it into standard use, so you can buy it right away now. Yeah. So it really depends on the kind of request that the customer has.
So to summarize some of the key points, so the vision for your R&D team is really about flexibility, and it's about designing to the customer needs, correct?
Exactly. And that's why we talk a lot, and I attend all, the internal meetings where we have our sales force and so on, and let's get the feedback into the machine.
Okay. Mm-hmm. How does that work with the our history?
Okay. You mean how the design process works together with our history?
Yeah.
So, yeah, I mean, the cool thing about Wenzel, and this is actually very a great thing to have as R&D, is that we have this high vertical integration depth. Yeah, you can go to the production line down there and talk to the guys who are actually doing the work, and this gives us a lot of flexibility, you know. We don't have long paths or something like that. We can just, if somebody designs something, he takes the drawing just from his desk. I think it's 100 meters down to the production line. You can actually talk to the guys who are doing the work, and that makes this, since we have that high vertical integration depth, this also gives us a lot of flexibility as to what we're doing. Yeah, you can put some things into that or that component, and I think one of the great things is that you, of course, we also have suppliers, yeah, but you know, it's always, you have to exactly define what you get delivered and all that kind of stuff. And I mean, that's fine, we can handle that. But if you have it in-house, then it basically means you don't talk about what's not working and the claim management and who's responsible for what, but you're talking about what makes the machine better. Mm-hmm. And this is, I think, one of the big advantages which makes for our design team quite a difference, yeah, to have this kind of influence on the production process and all that stuff.
So you don't just work on, your team doesn't just handle a design and make it in a vacuum. You can actually interact with the people who are going to build and fabricate the systems, and then work on designing for manufacturability and things like that.
Yeah, and that basically means that, I mean, when we start a project, then we typically set up a design team, and this design team not just only consists of some design engineers who sit here up in the office and that's it, but we have the prototyping department in the very early stages in the process. We make these intermediate, these intermediate meetings where we present what we design, and people are going always downstairs and telling people about their ideas and think about how to improve that or how to make it better for the customer or a better price for the customer. So yeah, this actually, I mean, it's a very integrated thing. Yeah, you start the design process not just in the R&D, but you start it with a team that's. I mean, there's also service in there. Yeah, you always have to take into account as to how you can service the components. So, for example, we have the CTL now coming out, and then people were always telling, "Oh, it's really hard sometimes to get into some corners and to exchange something," and we want to avoid that. So we put a lot of doors into the CTL. Yeah, if you look at the machine, then I mean, this quite costs some money in the design, but this means that if you look at cost of ownership, which makes for the customer a lot of difference, then you have a big advantage there. Yeah, and these are the sort of nudges we take from our colleagues from the production line and also from the service department, and integrate that into a product to get really the optimum result.
I think that's a key point too, is getting that feedback from the people in the field who service the machines, because they come up with all sorts of interesting tricks and tips and modifications that can make it simpler to maintain or more robust, which ultimately leads to cheaper cost of ownership for the customer and more uptime, which is really what everybody wants.
Exactly, and the more that the market evolves into the direction of having everything integrated into the shop floor environment, I think the mindset over there is quite different from what we had in the quality rooms. There we need the 100% uptime. We need to have reliable components. You have to have plannable cost of ownership and all that stuff. So also when you start thinking about how to design the machine, then you have to have a service plan in mind. How you can service the machine, how you can make sure that the uptime was really all the time there. Yeah, so I think that's a major point, and I think this is something where we both also have discussed in the past a lot about, which sort of shifted the focus since we had that impulse coming from the sales force telling us, come on guys, here cost of ownership is one of the major things for the future. You really have to think about that. And so we shifted the view there, and one of the examples is you had a lot of doors in the CTL where you can quickly and easily exchange something if something happens. And we put in reliable components which we are using sometimes for years, yeah. And so we are absolutely sure that we know quality is okay, and this will work, and it will work for a long time.
Excellent.
So thanks for that.
So, you talked a lot about the shop floor. Let's talk a little bit more about that family and that portfolio of products. So, what's new there, and how is this, kind of representative of what your department is trying to accomplish?
Yeah, so in the last years, we have, I think the SF55, this was the product that you guys in America have been selling at the very early stages. So this is actually something that has been around for a long time and where we have a lot of experience. And one has to actually say, I mean, for air bearings and so on, it's really working well in the shop floor environment. But at some point, people were saying, okay, we need a bit more measurement volume, and we want to have the three-sided axis because it makes quite a difference for the material flow, for handling the machine and so on. And that's how the SF87 came to life then. So this is a completely new design. I mean, it has something to do with a smart machine, which we had before the SF87, but we have now this cantilever design over here, which gives you actually great access. And I mean, there are also some like smaller things in there. Yeah, for instance, if you look at the tool change rack, it doesn't affect the measurement volume a lot. Yeah, this is also something that's what I said. This is sometimes the details, and this is what our application engineers were telling us. Come on, put that over there. If you put it over there, it doesn't affect what we're doing here very much, and you have a lot of space for your workpiece left there. And then I think when in the early stages, we actually didn't want to put the Revo on that. And at some point, then people from sales were coming and saying, okay, Revo is such a boost in speed. Yeah, you really have to put it in there. So in fact, we then put it in there, and we saw that you actually can have the productivity of this machine increased by a lot. And so I think you can see that this has been an interaction. The same goes for the SF1210. So I mean, I do the opposite example. If you put an LH2515 into your, so this is a gantry machine, into your shop floor, then you always have the issue as to how you orient it. It's really hard to put a workpiece in there. You only have two-sided axis. So this is quite the opposite of the SF1210. Here you have actually with this portal a flat bed, meaning that all the bellows and so on are just in one, on one level.
Right.
And and this is something where which I knew that always has been a bit of a problem, that people were talking to the customer and saying, okay, how do we orient this kind of machine into our shop floor so that we can easily put a work piece on that? And I think this is one of the things that we have resolved with this flat bed over here. You can just orient it in any way you like into the shop floor, and then it works. Yeah. And this sort of became a high accuracy variant also of one of our, let's say, older machines, which has been also a bearing guide machine, where we just put what our service guys told us. We did a steel quill in there with this linear guideways. So we did a big step here in the accuracy.
Excellent.
So also a lot of feedback coming in there.
From the experience we've had putting traditional LHs into automation cells and nearline manufacturing, the ability to rotate this machine any direction is a big advantage when we're planning the cell layout with the integrator or the customer. So I'm really excited about that part of the machine.
Yeah. And I think, I mean, this was one of the things where we had to look at the base plate more critically. And also we had to think about how to put the dual rod drive in there, which gives us a speed advantage. And so this machine is very rigid, you know, there are rod drives in there. So it has a very high dynamic, this kind of machine. And if you want to put it in a cell, that's exactly what you're saying. You can orient it in any way you like, and we can also have a higher throughput there.
which is the name of the game for sure.
Yeah, I think so too. Yeah.
So going back to some earlier comments, you talked about flexibility and making sure that, you know, one of the challenges your team faces is you can't just stick components together. They could work independently, but they have to work together as a system. So talk a little bit about the challenges with all the various products we offer. I mean, here's just an example of all the different types of sensors we offer, and you guys have to integrate this all into a complete system. So what's that like for you as a group?
So that basically means that software has to work very well together with the guys from the systems engineering who take care of controllers and all that kind of stuff, and also with the design team, because you have to fit in all that kind of probes and so on into the tool change rack. And this basically means that you also have a lot of variations. You combine all kinds of probes with all kinds of machines with all kinds of sizes. We have the LH machine or the XO machine with a 500 by 500 millimeters, up to the RAX. And I think the biggest one we ever did there was something like 4 meters high and I don't know, 20 meters long. So we have to really think about, when we design these kind of probes, as to how they fit in all the different kinds and sizes of the machines, and how we can have a like a toolbox system, where you just put in the controller, and if you just add this little box of or this toolkit variant of I don't know, scanning card or so, and it's always the right cable you have in there, and so on. So yeah, you have to think about this kind of situations in all the variations that you can actually have. But I think this is also quite some of the fun that we have in there. It's quite a challenge, and then we have to discuss how we can fit it in there.
That I'm sure that is. It's a lot of variations and a lot of different options, and everything has to work consistently too.
Exactly, yeah, and reliable. Yep. And I mean, this is one of the things why we did that controller in the scan box, where you can actually have like a modular design. You put in the scan box, then all the optical probes are working and so on, and it chooses the right thing there. Yeah.
So, what's changed in R&D in the time you've been involved with it here at Wenzel? Have you seen anything in the market demands change, or anything like that's been a challenge for you and the team?
So I think what's basically changing overall in R&D, and not only at Wenzel, is that we first of all have faster R&D cycles. So software came along. So I mean, if you look back 30 years or something, then hardware was the driver. You had the great car, or I don't know, and or some cool machinery, and this made up a lot. Right now we're at a stage where machine building has become sort of a tool that many people can do. They can't all do it on the same level that we are doing it here in the sub-micrometer range, but it's something that is more commonly there. And it has changed the mindset of people. I mean, you're used to having a new phone every 2 years, and it has a dramatic change for you. Yeah, it has some new cool features. You can have 3D photos, or the camera is changing, and this sort of get also into the R&D cycles of our products. So we always have to think about. This also means this transports to the hardware. Yeah, and we have to have cycles which are faster, and that means that we can't spend 2 years thinking about what to do next. It also means that you have to start a bit more volatile. Sometimes people are coming in between, and you have to talk to a lot of people what's their questions are to that project, and how to do it. So we have to be a bit more flexible in that kind of respect. And I think it's one of the good things, because it means that we're closer to the customer. We're talking to you guys a lot from the sales force. but it also has to mean that we have to think about different kind of strategies how to cope with that. Yeah, you can't just do the waterfall model of a project management where you have the first definition and then the definition is finished and you sign the document and from there everything is fixed. That's not how things are working right now. So yeah, we have to be more flexible and faster.
So there's more parallel development that goes on now than in the past.
Exactly, and you start with a bigger uncertainty, and but this also means that you have like faster iterations. You do a product, you put it on the market, you see how people are react to the product, and then you change the product in a certain kind of way so that it fits to the customer's needs better. And I mean, we're really
more software mindset, hardware mindset traditionally, like you said.
Yeah, exactly. They have something like they call continuous delivery, and the hardware guys, they have this very rigid cycle, or they had that, and they had to really change their perspective as to how to accommodate that. But I mean, from software and hardware, there are some major differences. For hardware, it means if you have delivery times of sometimes a quarter of a year, sometimes we had half a year. So you can't try something out and then say, okay, let's try it differently because you have delivery times. So this is quite different, but people are expecting it, and we have to somehow cope to that. And actually, we have become very, very good at that. So from the first scratch we did of some of our products to the actual working prototype, we had done. I think the fastest we did was actually 3/4 of a year. And if you consider now that you have to do all the drawings, that you have to have delivery times in a quarter of a year or something, then that's basically very, very fast. Yeah. So but it means that you have to make decisions at very early stages and then do one iteration after that. But it's actually working very well.
I think, a couple of the themes you've touched on, the vertical integration, allows us to control the ability that we can ramp our supply chain, and then the flexibility of having these different products to aggregate together and to put together sensors and things like that. And it's just not all developed in-house. So we're kind of spreading the development tasks out over different suppliers in the market, and then we bring it all together with the customer feedback and working to iterate based on their demands, like your example of the CTL with the modifications you made. So it seems like this all fits together well, and but it must be very challenging to manage for you and your team. And those are all very like technical and sort of operational aspects. What's a challenge that maybe isn't as technical that is interesting for you in the department?
So you mean as a technical challenge or not technical challenge? Sorry, didn't get that.
Yeah, a non-technical challenge.
A non-technical challenge. Yeah, from a management perspective, it means actually that that we have to overlook projects with a high uncertainty, and that means that we have to also change our management strategies as to how we handle all these kind of projects. So, for example, we have changed several of our departments to Kanban boards, which is sort of the agile strategy, and then we adapted that to products. To a product strategy where you have to fit in the software, where you have to fit in the hardware and so on, in order to get the throughput and still keep the overview of all these things. And this is something that also has to be that people have to incorporate. So it's not like it's a different mindset you go in there. Yeah. So also for people, it means that they can't count on everything. So before, let's look back 10 years or 20 years or something. If you had this kind of specifications for your project, then you always could look in there and always could tell people, come on, that's what you signed, that's what you get. Yeah. And so you have to change this kind of mindset where you say something new is coming up, where you beforehand perhaps have said, "Oh, come on, guys, we're just about to finish." Yeah, for instance, with the CTL, yeah, we're just about to finish, and now you're coming with that. And this kind of mindset has to be transformed and to change into, cool, that's a good idea. Let's do that and let's look at it. Perhaps it's something that all the customers want to have. Yeah. So I think the CTL we had in the very beginning was a very good example of that, where you have to actually look at it and say, oh yeah, well, that's a good idea. Okay, we have tons of work to do still, but anyway, let's do it anyway.
Let's do it anyway. Yep. Well, we're a little bit over time, so I have to get to a question. We've got a few questions that came in. Unfortunately, we can't answer them all, but one of our audience asked, if you look in the future, what's the most exciting development that you are looking forward to working on?
I think right now a lot is happening in the CT world. There's still a lot of work to do. I know that also standard specifications is still a challenge to be met. Actually, the optics is already ahead of the CT world in that respect. I think a lot is happening there, and I also see that having a software and hardware integrated product that fits the shop floor world in the automatization. So with all this MQTT, OPC-UA, and so on, and having this automation chain working perfectly and for the customer working perfectly, I think with automatic parts programming and so on, that there's also a lot to do. I think these are two things that we will have a lot of fun with in the next years.
Excellent, excellent. Mm-hmm. Well, I would like to thank you, Christian, for your time today. It's been a pleasure to talk to you, and I would like to thank our audience for
thank you very much for
attending and for their interaction. And these other questions that we have, we will get back to. We will reach out to you offline and send you some updates. So, thank you, everyone. Have a great day.
Bye-bye.